please see the next slide. Okay, the presenter is Engineer Ahmed Isahaku, Quality Control and Research Department of Sewage Systems Ghana Limited. Sewage Systems Ghana Limited is the private partner in terms of the Ghana case. And in sharing the leaders will be CSIR. So when it comes to the Ghana case, it is in two sections, the private partner and then the government setup, the research setup from the Ghana government institution. Now, as it has been established already, the overall objective is to co-develop a roadmap for widespread implementation of water-smart symbiotic solutions for wastewater reuse and resource recovery, of course, based on the principle of circular economy. Now, when it comes to the Ghana case, developing and demonstrating a value chain for the use of the treated wastewater for urban agriculture, and then promoting biochar usage as a substitute for wood fuel is the primary objective. Now, as I indicated earlier, the team comprises two sections: the private partner, that is Sewage Systems Ghana Limited, and then the CSIR. Now, within the CSIR, there are three sections. That is the statutory, the Water Research Institute, and then the industrial, and then the Institute of Industrial Research. So together we form the Ghana team. Now the private partner is the leader or the large industry in terms of wastewater and fecal sludge management in West Africa. And Ghana is proud to be, of course, the only participant from the African continent. Can we look at the next slide? Now, the next slide, you will see the narrow area the Ghana case is centralizing on, which is the urban agriculture as well as the fuel substitute. You can look at the next slide, where it will show the tasks. We have divided into two. We have divided them into two tasks. And the first task you see is the one that talks about the urban agriculture. Now, those individual tasks involve the evaluation of the current treatment plan that is going to be used for the case study. It involves, we first have to do the evaluation of the current state. Now, we also have to improve the effluent quality of the treatment plant that is going to be used for the pilot, for the irrigation, or for the farmers. And again, the effluents, the expected improved effluent quality will not be supplied to the farmers for the demonstration. Now, on the second aspect of the task, also involve the setting up of a plan for the pilot production of the biochar. Now, the biochar production line will also be installed and then optimized. Now, this optimization will involve getting a product that will have a high quality and well refined. And then this refined product will then be produced and supplied through the chain where it will be monitored, setting up the baselines at the end of the project. You can look at the next slide, please. So on the next slide, this time we are narrowing down onto the concept that's involved in the recycling of the water from the treatment plant. So next slide. So on the next slide, you see the concept. Now on the concept, first the concept, the whole idea is to improve the water quality. Now in this concept, there will be two stages of filtration system. That is after the wastewater treatment plant have finished the whole treatment processes, which involves the use of UASB, the tracking filter, sedimentation. So the effluent that comes from it is now the feed for our filtration system. And it can be, as it can be seen on the right, the picture, there will be a first stage which involves some filtration. Now there will be a second stage that involves activated carbon filtration. Now, after the activated carbon filtration, the final stage will be the disinfection stage to make sure that the microbial load are also handled. Now we can look at the next slide. Now this is a pilot that have been done prior to this project. This gave the idea and the confidence that this recycling project is going to be successful. Now, if you can see on the right, the one on the left is the final effluent from the wastewater treatment plant, and the one on the right is the one that has been piloted to see or to confirm that it is possible to recycle the effluent water from the treatment plant for irrigation. Now we can look at the next slide. Now this system actually, once it is generated, the picture you saw on the right is going to be the final one for the farmers. And the idea is to serve the farmers along some areas or targeted areas that actually have to rely on some untreated water along some streams, some drainages, etc. Now, this effluent water is going to serve that purpose to make sure that all these things are handled. Now, look at the next slide. You see some potential challenges that we envisage to happen. Now, because the water to be supplied to the farmers is going to come from a wastewater treatment plant or a sewage treatment plant, we envisage that the acceptability of that product for the farmers will be a challenge. Again, the filtration system, we envisage potential blockages as the feed comes from the effluent treatment plant at some level of suspended solids. And then also, the last one, which is the biggest, is incomplete disinfection could have a potential health risk to the farmers if it's not able to achieve. However, we can look at the next slide. We've tried to mimic the situation and then develop some measures. Now, we believe that the involvement of CSIR in this project, the institute comes with a big name. Now, with their involvement, we believe is going to gain the confidence of the farmers for them to believe or accept the products that we are going to supply. Again, in terms of operation, the blocking of the sand filters, we believe we have instituted a backwashing system such that we've run for some hours, then we do backwash. So we can keep the blockage of the sand filters during the operation. Now, again, to make sure that the final effluent is well disinfected, by removing all microbial loads, we want to run on a batch system so that we are very sure that after every filtration setup, the required volume is obtained, then the disinfection will be done, completed, sampled, analyzed, then it can be released to the farmers. In that case, we know we are going to handle the issue with the incomplete disinfection. We can look at the next slide. Now, that's the second task of the Ghana case. That's the production of the biochar. Next slide. Now we'll look at the concept. Now the whole concept is going to be the sludge. That is, this sludge is a primary sludge. It has not gone through digestion. Now this is obtained through dewatering in the fecal sludge treatment plant. When it is obtained, it's going to be dried. Now when it is dried, it will be crushed, not completely into powder, as it can be seen in the picture on the right side. It will be crushed, then it will be carbonized in a kiln. Now, after the carbonization, it will be grounded so that it will mix with the binders. After mixing with the binder, then it will be molded into shapes. Now, after the molding, then it will be dried to the expected moisture content. Now, let's look at the next slide. On the next slide, you will see some sample of the dry sludge, the harvested carbonized biochar, and then on the far right with the coal pot, that is a typical case of Ghana where we use in cooking. In it is the sample of the molded biochar that have been obtained from the manual way of generating. This is the concept that we use to confirm that yes, it's possible when we scale it up for this project. Now we can look at the next step. The idea of this biochar production is to substitute as fuel base. In this case, we are targeting the charcoal, which actually comes from the wood base. Now, in replacing this, we believe, talking about the circular economy and other things, we we believe that substituting this also going to help in the green environment within our scope. So this is the idea, and by the time this project ends, then the baseline will be set up, the policies will be generated, and all the documentation will go to. We can look at the next slide, so that this is the potential challenge we perceived or we envisage. If sand happens to contain in the sludge, then the final product has the potential to have a low heating value or current, and of course it will affect the burn rate. Again, the biochar having come from a fecal sludge base is going to be difficult for the public to accept. Again, the base or the feedstock of this is coming from dewatering, and therefore we envisage that in the absence of dewatering, then our feedstock base is going to be affected. Now, incomplete carbonization has the potential to generate smoke during the use of the final product, and this also may lead to some potential health risks. We can look at the next slide to see the measures we are putting in place to curb these potential challenges. To deal with the sand mister, we will be introducing a separating layer to separate the sand surface and then the sludge that will be introduced on the sludge bed. This to deal with the sand issue. Now, in the terms of acceptability or the product acceptability, we believe that, again, the involvement of the strong force CSIR is going to set up the pace for people to believe in the product, as the Institute for Industrial Research are also involved on CSIR, and all the tests will be done and conducted to ensure that all the parameters are within. So we believe that with this support, the public or the users are going to accept products. Now, alternative sludge sources have been put in place in the event that there is no dewatering to ensure that our feedstock is available. We are going to rely on the secondary sludge by pressing it to bed press, and then we use it as the alternative feed to ensure that the project or the issue with feedstock is handled. Now, the incomplete carbonization, what have we put in place? The operation of the kiln. We are going to ensure that it is well optimized, such that it can be predicted even from the characteristics of the feedstock and then the operating temperatures of the kiln. We can even predict before starting operation, and this will come from the optimization, just to ensure that before we feed our sludge, we are going to get a very complete or a well carbonized biochar. Now we can look at the next step. And here we are saying thank you, Ghana being the only country from Africa. We are grateful to be part of this project. Thank you very much.